What is, yes. So we are moving 40 to the other side indeed, but then the left-hand side must be, yes. So d squared minus 3d. So now this is a trinomial. First of all, it's degree 2. How many solutions we have to come up with? 2. Very good. So descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, I wish. But at least 1 is the leading coefficient, so I can directly go to factoring once I find those numbers. So I'm looking for two numbers whose product is how much? Negative 40, and whose sum is negative 3. Because the product is negative, we know for sure we are looking for a positive and a negative number. That's why the product is negative. And those numbers are, very good, negative 8 and positive 5. The sum is negative 3, yes. The product is negative 40, yes. And we can directly write d minus 8 and d plus 5, only because the leading coefficient was 1. That is not possible when the leading coefficient is not 1. Okay, so then you'll give me two solutions as expected. From here you will give negative 5. Maureen, you want to teach for me? I can sit down and relax. Well done. Okay, let's look at the last one here and then look at the book. 1/2 x squared plus 5x plus 25 divided by 2 equals 0. And we're done with these handouts. It doesn't mean that I don't want you to throw them away. I think you should always go back and refer to them later. But if you know that very well, then you can obviously get rid of them. But we're not going to come back to them this semester, I think, unless we review or something. Yeah. Okay, I see fractions in an equation. Fractions in an equation. No, we're not scared of them. What do we need to do? Immediately.
Multiply everything by that 2.
By the least common denominator, which is 2, and the whole thing becomes more human, right? When we multiply the first term by 2, what do we get? Yes. When we multiply the second term by 2, what do we get? Excellent. And when we multiply the third term by 2, what do we get? 25. It's 2 over 1 times 25 over 2. And the right-hand side is? Very good. Now this is friendly. Descending order, yes, it's a trinomial. Degree 2. We expect two solutions. It's in descending order, no greatest common factor, no negative leading coefficient. I hope for a special product. Is this a special product? Is this a special product? Yeah, because this is x squared and this is 25. And this is positive. What do you expect?
Binomial square.
Which is?
X plus 5.
Good. But I'm not sure. I haven't checked the middle term. Now, this expansion has a middle term. If you expand this, it has a middle term. 2 times x times 5. How much is that? 10x. If the middle term here that is covered now is not 10x, I'll say this is incorrect. Oh, it is 10x. So then you're going to give me two solutions, however, they will be the same. Very good. So x equals negative 5. Well done.
So this is a quadratic, and if you graphed it, you would get two identical solutions, which means what, graphically?
Excellent. It will only touch the x-axis in one point.
Okay.
It will not cross the x-axis
So
in two distinct points. It will just, the vertex will be right there. Very good question. Okay, I read this very carefully. It only specifies solving by factoring. There are 3 other methods. So I guess my colleagues decided do not discuss the other 3 methods. Fine. Okay then. So here's from the book. And they only say solving by factoring, not the square root property, not completing the square, and not the quadratic formula. So here they are. Let's choose. I can't say, I wasn't involved in this. I'm on the calculus committee, so I don't know how the decision was made, so I can't see what the reasoning is or tell you what the reasoning is behind it. So we are only interested in solving by factoring right now. So please choose anything you feel like it.
7.
You want to choose 7. What else? 7 is 1. Anything else? 12. 7 and 12. Anything else? Which one? 10. Anything else? Number 6. Anything else? Let's also do 14. I think we had enough. We already had like 8 problems already. I think this should be good. So let's take a look. Okay, so I'm going to start in order. 6. In 6, we have 9x squared plus 9x plus 2 equals 0. Good pick. Okay, it is quadratic. I expect 2 solutions. It's in descending order. Greatest common factor in all 3 that I could get rid of, not x, ever. Is there a common factor present in all 3 that I could divide by? No. Negative leading coefficient? No. Special product? I always wish for a special product. Yes, if you only look at 9x squared. But no, if you look at 2. 2 is not a perfect square. So a special product would not work. Okay, my next level is, I'm hoping for 1 is the leading coefficient. Yep, I'm not in luck. Okay, then, fine. So I'm looking for 2 numbers whose product is and whose sum is. What is the product?
18.
Awesome. What is the sum? 9. We always start with the product. The product is positive. So it means I'm expecting 2 positive numbers or 2 negative numbers. But the sum is positive. How can I add 2 negative numbers and get 9? So then, obviously, I'm looking for 2 positives. What are they? Indeed, 3 and 6. Remember, because the leading coefficient is not 1, you cannot write this. Nope. Nope. We have 9x squared plus 3x plus 6x plus 2 equals 0. We have to use these 2 to break or change, if you like, the trinomial into a polynomial. If you go back and combine like terms 3 with 6, 3x with 6x, you are going backwards. So from the first 2, what do I pull out? Awesome. What do we have in parentheses? What do I have to have in parentheses? Do not forget the equal symbol and 0. This is not a factoring situation. This is a solving of an equation situation. What do I have to have in parentheses so I don't make an error? I have to write it. And now I need a sign. If we forget the sign, we omit a very important part of the problem. Plus. Excellent. The common factor goes out, which is? Excellent. And now we have one more factor, which is? And now you're going to give me 2 solutions. And they are distinct. 2 solutions.
X equals minus 1/3.
Excellent. And minus 2/3. These are our solutions. I know you all understood what's happening here, but if you don't practice, you're not going to remember this. Okay, we move on to number 7. So we have 6, 7, 10, 12, and 14. Any questions on number 6? Okay, number 7. Three x squared minus 2x equals 8 on page 167. So they're all from page 167. Okay, ready? What do we do? Yes, we move 8. It's quadratic. We have to have 0 on one side. Perfect. So 3x squared minus 2x minus 8 equals 0. Trinomial, descending order. Yes. Greatest common factor. No. Negative leading coefficient. No. Special product. No. 1 is the leading coefficient. Yet no. Oh well. So I have to find two numbers whose product is and whose sum is. Indeed, and negative 2. We always start by looking at the product. The product says it's negative. So then 1 must be positive and 1 must be negative. Negative? 12 and 2 will not give us a sum of negative 2. Negative 6 and 4, I completely agree. The product is negative 24. The sum is negative 2, yes. Because the leading coefficient is not 1, you cannot immediately factor it. You have to go through the process of 3x squared minus 6x plus 4x minus 8 equals 0. From the very first two terms, I will have to pull out what? What is left in parentheses? What do I have to have coming from the other two set equal to 0? Otherwise, I can't continue. Okay, now I look. Only now. I look and I need a sign and a factor. Sign? Excellent. Factor out?
3x plus 4.
Yes, but that's fine. You can do that. It's nothing wrong. I just want to keep it in the same order so I don't confuse anyone. Hopefully. Okay, two options then. As expected, x equals, x equals.
X equals 2.
Indeed, x equals 2. Negative 4 over? Excellent. Well done. Okay, so this was 7. We move on to 10. Here's 10. 5 x squared minus 20x equals 0. When the free term of such an equation is not there, this is the easiest possible type of quadratic. Okay, we want to clean it up. We want to simplify it first. What will I simplify both sides by? Which number? Never x.
5.
Indeed, I will simplify by 5. So x squared minus 4x is 0. It's a binomial. It's in descending order. Does it have a common factor? And the answer is yes. It has a common factor, which is? Very good, awesome. So then x minus 4. So that's it. We are ready to write the answers. That's the easiest. Just remember, if the last term, the free term, is missing, this is the easiest type of quadratic equation. So then x equals and x equals. Can anyone give us two solutions? 0 and 4. Excellent. So we had 10, we still have 12 and 14. Twelve. 16x times x minus 2 equals 8x minus 25. And then 14. Yes, absolutely. And at the same time, to save some time, I will distribute 16x. So 16x squared minus 32x minus 8x plus 25 equals 0. Let's stop for a moment and see if you have any questions on this step. Any questions on this step? So I distributed 16x to x and to negative 2. And then I moved 8x to the other side and negative 25 to the other side. So if a term is positive on one side, when we move it to the other, it changes its sign. When it's negative, it's positive on the other side, and the other way around. Okay, so we combine our terms now. We get 16x squared minus 40x plus 25 equals 0. Always try to simplify your life. So if I simplify this, if this equation is simplifiable, I should, but it's not. 16 and 40 and 25 do not have a common factor I can get rid of. So then it's a trinomial, it's in descending order. No greatest common factor, no negative leading coefficient. Special product, I always hope and wish for a special product. Because then I'm done. I don't have to do anything. It's the easiest thing to do. Okay, is the first term a perfect square? Is the second term, is the last term a perfect square? Good. And there is a minus in here. So what do you expect then? But we haven't discussed the middle term. I would like someone to give me the middle term of this expansion. 2 times 4x times 5. 2 times 4x times 5, or 2 times 5 times 4x, the same thing. Negative 40x. If I uncover a negative 40x, then I'll say this is correct. If I don't uncover negative 40x, it's incorrect. It happens to be true. So then we have to find two solutions, however, they are the same. How much is x in this case? 5/4 indeed. Okay, last one here. And then we'll look at rational expressions. 14. In 14 we have 10x minus 1 equals 2x plus 1 squared. Let's work on this for 2 minutes. Let's see what we get. I just want to hear one answer from you before we look at this problem. The right-hand side is a binomial squared. How many terms will you write? Yes, a binomial squared has 3 terms. Please, we have that in our agreement from last week. So please do not write 2 terms. Please. Okay? That was my first hint. Or maybe the only hint I have for you here. Bob, you want to say something?
The second thing I would probably recommend not doing is moving the 2x plus 1 over and making it a negative 2x plus 1.
You can't.
You can do that way, but
not before you square.
okay.
You cannot remove 2x from inside the parenthesis and move it to the other side.
No, the whole term over to the other
side. The whole term, yes, you can.
That kind of gets messy.
Yeah, but it's okay. But if you'll have 3 positive terms, it's better to move the other 2 to the other side. It doesn't matter, really. It's not such a big difference. It's up to you. Same thing. Sorry, I misunderstood. My apologies.
No problem.
Let me know if you need help. I'll come over and help you. Please. Do we have an answer or not yet? We have an answer? Okay, let's start. Okay, so the left-hand side is 10x minus 1, and the right-hand side, can anyone give us the right-hand side? I hope you're not still foiling it, but there's nothing I can do. This is too important to still factor foiling. So, first term squared. First term squared. But it's squared. 2x squared, how much? 4x squared. Plus 2 times 2x times 1. 2 times 2x, 4x, very good. Plus the second term squared, which is 1. So now let's move these terms to the other side. So we have 4x squared plus 4x plus 1 minus 10x plus 1 equals 0. What is the next step? Yes, awesome. So we have 4x squared minus 6x plus 2 equals 0. I always hope to be able to simplify a little bit. Can I simplify a little bit? Yes. By? Yes. Because it's an equation. I can get rid of it. I don't have to keep it as a factor in front. So this will be 2x squared minus 3x plus 1 equals 0. A special product is not applicable here. 1 is not the leading coefficient. Again, I'm down to the last option, in which I'm looking for two numbers whose product is and whose sum is. What is the product? 2. What is the sum? Excellent. So the product is positive, meaning I'm looking for two numbers with the same sign, either both positive or both negative, but the sum is negative. So obviously both have to have which sign? Negative. So negative and negative. Negative 2 and negative 1. So now we replace the middle term. You cannot go directly to factor it because this is not 1. So then we have 2x squared minus 2x. Oops. I'm going to write minus x and plus 1 equals 0. Sorry, it's minus x. Good. Do not go backwards and combine like terms. You're not going to factor. Okay. From the first two, what do I factor? Out. Indeed. What is left in parentheses? Very good. What do we need from the other two? Otherwise, we can't continue. Very good. Now, only now, I uncover and see what's in there. I need sign and factor.
Minus 1.
Indeed. Common factor out, which is? And what is left in parentheses? So then you're going to give two options, two possible solutions. And they are x equals 1, very good, or 1/2, very good. Great job. So our next step. So let me show you where we are. And I'm hoping you're completing your homework every day. I can look. Please complete your homework after you redo the problems we did in class. So this was covered. This was covered. Substitution. This was covered. The elimination method. The general strategy. We worked for more than 2 hours on this. That's covered. We did P.5, covered. We picked problems from there. Solving quadratic equations by factoring 1.5, done. We just picked several problems from 1 through 13. And simplifying complex fractions, no, we cannot jump to this. We need preparation. So we need preparation before we do 2.3. And then solving rational expressions. Okay, so here's our next topic. Rational expressions. Rational expressions. I know I only have about 7 minutes left. I just want to introduce the idea and how to simplify rational expressions, and then we'll continue on Monday. Okay, so here it is. A rational expression is, I'm going to abbreviate RE, rational expression, is a ratio, fraction in other words, of two polynomials. That's the definition. A rational expression is a ratio or a fraction of two polynomials. Examples. X squared minus 36 divided by x plus 6. 1 over x. X minus 1 over x squared minus 1. X over x minus 1. And so on and so forth. All these are rational expressions. As long as they have x in the denominator, they are rational expressions, and of course a ratio of two polynomials and x in the denominator. This, for example, is not a rational expression. It doesn't have x in the denominator. It has a ratio, but it has to have x in the denominator. You can say, but 4 is a polynomial, degree 0. True, but a rational expression requires x in the denominator. Okay, so I'm going to analyze a couple of these. So one rational expression is 1 over x, one of these 4 examples that I gave. Okay, so if I ask you to determine the domain of this expression, what will you say? Or maybe I ask you, what is the value of x that you will not be able to evaluate this expression for? If I ask you evaluate for 2, you'll say 1/2. If I say evaluate for 1, you'll say 1. If I say evaluate for -2, you'll say -1/2. But there is one specific number that I cannot ask you to evaluate for, because you will not be able to give me a number, Jay. 0. Why? We wrote this last time or last week. Division by 0 is called undefined. So I will have to say x is not 0. And then what is the domain? Well, in plain English, anything but 0. And here's how we write it. Union 0 to infinity. In plain English, everything but 0. The parenthesis means 0 is not included. The parenthesis means 0 is not included. 0 is excluded from both intervals. Okay, we'd like to talk about this one now. Let's say x divided by x minus 1. which is the value of x that I should never, because I'm not going to get a number back, ask you to evaluate.
1.
Exactly. So x minus 1 cannot be 0, which means x cannot be 1. So how will I write the domain of this expression then? Negative infinity to, exactly, and parenthesis union 1 to infinity. Excellent. Very good. Okay, let's look at x minus 1 over x squared minus 1. And let's find the domain of this one. Okay. Well, the top is the top. I don't care about the numerator. The numerator can always, it's free, absolutely free and independent. It can be anything. But I know now from reviewing our factoring strategy, I know that that is completely factorable or is factorable. How? How do I factor this? Excellent. Is the difference of squares x minus 1, x plus 1. Without looking at the numerator, can you please give me the restrictions? X cannot be what? From here and from here, negative 1. So plus or minus 1 are not allowed. However, and that's correct, and that's the domain. We're going to write it in a moment. However, notice that I can simplify by this factor called x minus 1. So this is a very important note. Note, simplify only factors. That's one of the reasons why we learn how to factor, because this is the second application. Not just, the first one was solving quadratic equations by factoring, and this is the second one. Simplifying rational expressions by factoring. So the simplified form is 1 over x plus 1. However, this is the domain. Although you no longer see x minus 1 in here, it doesn't matter. The domain is still this, meaning negative infinity to negative 1, union, negative 1 to 1, union 1 to infinity. Again, in plain English, everything but 1 and negative 1. So we do start by stating the restrictions and then stating the domain. Any questions? Any questions? Okay, well, I already